Welcome to my YouTube channel for my online analytical chemistry tutorial. Again, this is Professor Indelin C. Gomez, your online tutor. Today we are going to solve mixture problem. This is under the topic precipitation gravimetry. Now here is the problem. A mixture containing only ferric chloride and aluminum chloride weighs 5.95 grams. The chlorides are converted to hydrous oxide and ignited to ferric oxide and aluminum oxide. The oxide mixture weighs 2.62 grams. Calculate the percent iron and percent aluminum in the original sample. Now, as first step in solving the problem, first we have to identify all given. In this problem, we are given the mass of sample, 5.95 grams, and the mass of precipitate, 2.62 grams. We are asked, okay, so we have to write it down here. So here they are, mass of sample, 5.95 grams, and mass of mixture of oxides, 2.62 grams. And we are required to calculate percent aluminum and percent iron in the sample. To calculate percent aluminum, this is percent aluminum equal to mass of aluminum over mass of sample times 100. Also, for the calculation of percent iron, this is equal to mass of iron over the mass of sample times 100. Now, before I proceed to my calculation, let me show you first how aluminum and iron are determined from the mixture. Now, this is the flow diagram of the analysis. We have the mixture here. We dissolve our mixture with water or maybe in dilute acid to transform aluminum and iron into ions. Then we add precipitate or we add this precipitant. Now, this precipitant converts aluminum and iron into hydrous oxides. Aluminum is converted into hydrous aluminum oxide and iron is converted into hydrous ferric oxide. Then we filter the solution, then wash and ignite at high temperature. Then after ignition, we obtain these mixtures of ferric oxide and aluminum oxide. And this has mass of 2.62 grams. Now, going back to our calculation. Now, take note that our mixture is composed only of two pure substances, the aluminum chloride and the ferric chloride. Therefore, this 5.95 gram sample is simply equal to the mass of aluminum chloride plus the mass of ferric chloride. So, we can let X represents the mass of ferric chloride and 5.95 minus X be the mass of aluminum chloride. Now, we also have here another equation. 2.62 gram equal to mass of ferric oxide plus the mass of aluminum oxide. We can calculate the mass of ferric oxide from the mass of ferric chloride. And also, we can calculate the mass of aluminum oxide from the mass of aluminum chloride. Now, to solve for the mass of ferric oxide, we have to convert this mass of ferric chloride into mass of ferric oxide using this factor. And also to convert this mass of aluminum chloride into mass of aluminum oxide, we have to use this factor. So here it is. 2.62 is equal to X grams of ferric chloride times the molecular weight of ferric oxide divided by 2 times molecular weight of ferric chloride. I multiply 2 or I multiply ferric molar mass of or molecular weight of ferric chloride by 2 because 1 mole of ferric oxide is equivalent to 2 moles of ferric chloride. Okay? Now also, 5 minus 95 minus X grams of aluminum chloride is multiplied by molar mass or molecular weight of aluminum oxide divided by 2 times molecular weight of aluminum chloride. Again, I multiply this by 2 because 1 mole of aluminum oxide is equivalent to 2 moles of aluminum chloride. Okay, now substituting all the values, we have this. Okay, so 2.62 is equal to x grams of ferric chloride times 159.69 grams of ferric oxide divided by 2 times 162.21 grams of ferric chloride plus 5.95 minus x grams of aluminum chloride times 101.96 grams of aluminum oxide divided by 2 times 133.34 grams of aluminum chloride. So here, grams of ferric chloride and grams of ferric chloride cancel. Also here, grams of aluminum chloride and grams of aluminum chloride cancel. Now we have this new equation. This first quantity here was obtained by simplifying this and multiply by x. Okay, so here it is. And then also the second quantity was obtained by simplifying this and then multiply this by 5.95. And the last quantity was obtained by simplifying this and then multiply this by x. Okay, so rearrange, collect all similar terms, and solve for x. So the value of x is equal to 3.14 grams ferric chloride. Now, since we have the value of x, we can now solve for the mass of aluminum chloride because mass of aluminum chloride is simply equal to 5.95 minus x. So, mass of aluminum chloride equal to 5.95 minus 3.14. And this is equal to 2.81 grams aluminum chloride. So since we have now the mass of ferric chloride and mass of aluminum chloride, so we can now calculate the mass of iron and mass of aluminum. The mass of iron can be calculated by converting this mass of ferric chloride into mass of iron using this gravimetric factor. And also, the mass of aluminum can be calculated by converting this mass of aluminum chloride into mass of aluminum using this factor. So for mass of iron, this is equal to 3.14 grams of ferric chloride times 55.847 grams of iron over 162.21 grams of ferric chloride. So ferric chloride and ferric chloride cancel. So the mass of iron is 1.08 grams. So to calculate percent iron is equal to 1.08 grams iron divided by 5.95 grams sample times 100. And this is equal to 18.1%. Now to calculate mass of aluminum, this is 2.81 grams aluminum chloride times 26.982 grams of aluminum divided by 133.34 grams of aluminum chloride. So grams aluminum chloride and grams aluminum chloride cancel. So the mass of aluminum is equal to 0.57 grams. So percent aluminum is equal to 0.57 grams aluminum divided by 5.95 grams sample times 100. And the answer is 9.6%. So I hope my discussion is clear. Now, if you like this video, please like, share, and subscribe. Thank you for viewing.